Combination circuit, question 1. In this combination circuit, we're wanting to find the current at these three locations, A1, A2, and A3. We're given a total voltage of 24 volts. We're also given that the resistances are 10, 5, and 10. However, we don't have any total resistance nor the total current. So my first goal would be to find the total resistance. Now the total resistance is going to be the 10 ohms that is in the series part of the circuit, and then I have to calculate with R1 and R2 what this circuit is here. So I'm going to find the resistance of this parallel section. So resistance of this parallel section is 1 over 5 plus 1 over 10. Doing this calculation gives me a resistance. I should put that as that, sorry. Doing the calculation gives me a resistance of 3.33 ohms. Therefore, the total resistance in this circuit is 10 ohms plus the 3.3 ohms. This allows me to calculate the total current in the system. So the total current would be the total voltage divided by the total resistance. Therefore, it's going to be the 24 volts divided by the 13.33 ohms for a total current of 1.8 amps. Knowing that, it solves for A1. So A1 is 1.8 amps. That's because the current in the series part has to be the total current. So as it moves through, now it will split. It will head more through the 5 ohm resistor than it would the 10. So I can calculate that out, knowing that 1.8 amps. So here, the 1.8 amps is going to be split. So for A2, which is this one, it's going to be the majority of it, so 10 out of 15. So 5 plus 10 gives you the 15. This one's blocking with 10 ohms, therefore majority of it will go this way. So using that percent, we find that the current through A2 is 1.2 amps. And the remainder, so 1.8 minus 1.2, would be going through A3, and the remainder there would be 0.6 amps. So in total, you have 1.2 amps going through the top part of the circuit here, through R1, which is more because the resistance is less, and then less current, 0.6 amps, running through the resistor 2, which is 10 ohms, because there's more resistance there, leading to less current wanting to flow. Both of those would come back again at this juncture, where they would add up to 1.8 amps again and pass through this resistor and back to the battery.